next week. Okay, I figured we would deal with it that way versus making it another whole lesson and add on to a big quiz. Okay. And I will talk about the schedule this week here in just a minute. Let's get to here. Nope, that's not the right class. This one. There we go. Okay. So what we're talking about here, okay, is we have a rational expression, right? A fraction. Whenever we have a fraction and we try to graph it, it has two branches, okay? It looks something like this, okay? The thing that it gets really, really close to is what we call an asymptote. I'm not going to try to write out the word and try to spell it right because I never do. Asymptote, okay? An asymptote is like an assistant in the graph that helps us graph something. We can get the graph gets really, really close to it, but never crosses it, okay? So it's like a graph assistant. Sometimes we will find that there is something that we cancel out, and so we end up having a hole in our graph. Our calculator will never show the hole, okay? So a hole is what cancels, okay? And a vertical asymptote is what's left behind in the denominator. Left behind in denominator. Okay? As with most things in Algebra 2, look at that denominator. What do you think we should do first? Let's do a magic X. Yeah. It's like this seems like all we do, right? All year long. That's why you had to get really good at them. Okay, so two numbers that multiply to -6 and add to -1. -3 and 2. So I have my new function f of x equals x plus 2 over x minus 3 times x plus 2. Okay, we've seen this before where things cancel in a function. So I noticed that this and this cancel. Okay. So where it cancels is a hole. I'm going to take what I just canceled and I'm going to set it equal to 0. So if I move the 2 to the other side, how do I do that? Subtract. So my hole is that x equals 2. Okay. Now I'm going to finish my algebra over here. Okay, so that's what the function, that's an equivalent function. Okay, so it would likely graph that. Okay. I'm going to set what's left in the denominator equal to 0. So this is going to be my vertical asymptote, which I am abbreviating because I cannot spell it. All right. I'm going to set what's left behind in the denominator equal to 0. So what do I get when I set that, or what do I get for my vertical asymptote? Yep, and it's x equals 3. You have to have this because it's talking about a vertical line. Line is x equals. Okay. So if I was going to actually graph that one, okay, and this is just a sketch of it, because what I graphed before was not that exact one. I would have an asymptote at 3, so somewhere along here, okay? And then I would have a hole at -2. So I'm going to graph this side of it. It would kind of look like that. You don't have to do the graphing. I'm just trying to give you an idea. Then at somewhere at -2, like right here, there'd be a hole in the graph. So it looks something like that, okay? So we'll keep worrying about the picture later, okay? Right now, I just want you to be with algebra, be able to understand where is the hole and where is the asymptote. Okay. All right, so I'm going to give you a couple to try on your own. Remember, all of our factoring skills come back. It might not be magic X. It might be differences squares. It might be grouping. It might be greatest common factor. Okay, it might be magic X and box. Okay, it could be any of those things, but you start with factoring the denominator. All right. So see what you can do on that one. Find the holes, find the asymptotes. There could be more than one. There could be none. Okay. But everybody try it. About 20 seconds on your own. Make sure you try getting both the whole and the asymptote. You should be participating. This is your opportunity to make sure you know this stuff. This is going to be our skills check question on Friday. Okay, let's take a look. All right, what type of factoring was this denominator, everybody? What do we call it? Difference of squares. Perfect. It looked like most people got that. So we had to do square root of x squared is x, square root of 16 is 4, make one a plus and one a minus. X minus 4 canceled, that became the whole. So your whole was at x equals 4. And then your function was reduced to 1 over x plus 4, and then you set your denominator equal to 0, and we got that x equals negative 4 is the asymptote. And that's not just asymptote, it's the vertical asymptote, because technically we have some horizontal asymptotes here. Oh, look, this person even tried to graph it a little bit. Nice. Okay. All right. Thank you. It's vertical asymptote. Like I said, we're going to deal with horizontal next week. Okay. All right. Let's do one more. Try that one. Give you about 15, 20 seconds on your own. Okay, let's take a look. Got a good one. Lots of people on the right track. This will be the nice part, the easy part of the week, right? We'll see if it'll. There we go. Okay, so we do our magic X. We got two numbers of multiplied negative 10 added to 3, 5, and it was negative 2. We didn't get a negative there, but the negative landed here, so that was good. And so we rewrote it, and then we noticed that the x plus 5's matched, so we cancel those out. That becomes the whole, so we set that equal to 0. We got x equal negative 5 is the whole. Okay. And then what was left behind was the x minus 2. So x minus 2 equals 0. And then we add that to the other side. So x equals 2 is the vertical asymptote. Okay. All right. That's all we're going to do there. Let's take a look really quick at the schedule. I've started laying it out a little bit. I don't have it all in there. I know that we have some people who are on the cheer team, and they are going to Florida this week. I'm going to hit this button over here so I can stop this. Oh,